Okay, so you had a question on 1 through 4 here. I just picked this section 8.2 and 8.6 worksheet, but really they're all of those are the same no matter which one you are in possession of. So we're going to draw a right triangle that has an acute angle, and the way we'll do that is we'll draw it in the first quadrant. So if we come out of the first quadrant, out of the origin like so, and draw back down to the x-axis, you've created a right triangle that's acute. Use the Pythagorean theorem to determine the third side. Well, before we can do that, we have to look at what we know. Cosecant is the flip of sine. Sine is y over r, so cosecant is r over y. So the r is the square root of 39. And the y side, the vertical side, is 5. And now we can find the missing side, the x side. And you can either do that through the Pythagorean theorem. I'll make this a little bigger now so we can see it a little bit better. The Pythagorean theorem, the long way, which is a squared plus b squared equals c squared. Or, in other words, 5 squared plus something squared equals the square root of 39 squared. So 25 plus b squared equals 39. Subtract 25 and we get b squared to be 14, and the square root of that is b. So the missing side here is the square root of 14. And now, with that completed picture, we can answer any trig question that's asked. In this case, we want the tangent, which is y over x. So I will just simply put the y side 5 on top of the x side square root of 14, and realize that you can't have a square root in the bottom, so we want to rationalize this. So the answer we'd be looking for is 5 square roots of 14 over 14. Sine, I just scribbled through it kind of, but sine is y over r. So we could take the 5 and put it on top of the radius of the square root of 39 and do the same rationalizing and get to 5 square roots of 39 over 39. So that's how that's done.